In this lecture, we will discuss how the ArrayList class is implemented.
Before we get started, I should mention that to avoid any ambiguities with the already existing library class, we're going to call this class myArrayList. We're not going to provide a myCollection or myList interface. Rather, myArrayList is just going to be standalone. Now, before we actually even look at the code, we're going to look at the main details of this actual implementation. So myArrayList is actually going to contain the underlying array data structure. It's going to store the capacity of the array and also the current number of items that's stored in the myArrayList. Now, since we do have a capacity, the myArrayList implementation will also give us a mechanism to change that capacity. So if we need to add more to the array, we can do so. And the way we're going to do it is we're going to create a new array, and then we're going to copy the contents of the old array into the new array. And then the virtual machine will take care of reclaiming the old array. So it'll use garbage collection to do that for us. MyArrayList will provide an implementation for the get and set methods. It'll also provide basic routines, such as the size, isEmpty, and clear methods. These are just going to contain one line of code in them. They're really simple. It'll also contain a version of the remove method, and it'll also contain two versions of the add method. I should mention that for both versions of the add method, it will increase the capacity if it finds that the current size of the array and the capacity are the same, because if that were true, then we can't add anything more to the array unless we increase the capacity. Finally, myArrayList will give us a class that implements the iterator interface. So this class is going to store the index of the next item in our iteration sequence, and it'll also give us implementations of the next, hasNext, and remove methods. The iterator method that's associated with this class will just return the newly constructed instance of the class that does implement the iterator interface. So we're going to have the complete implementation of the iterator interface in this program. We'll now take a look at the complete class.
Let's now take a look at the code for the complete class here. So we have public class myArrayList implements iterable. So we know we're implementing the iterable interface. And as we mentioned before, we're going to call this myArrayList just so we don't confuse it with the ArrayList class, although it's very similar to the ArrayList class. So we have a constant here, which is called default capacity, which means whenever we create an initial object of the class, if we don't specify any particular size for the array, the default is that we're going to have 10 items in the array. And as we'll see, we can increase that whenever needed. Our two main variables would be the actual size of the array. So even though we have a default capacity, we are given the size that the array technically holds. And then we have the array, the items, as our underlying data type. So we have a default constructor that's going to call doClear. So we're going to see what doClear does in just a second. And then we have the clear method, which also it calls doClear. So this is going to clear the array. So now we see the doClear method. So we're going to set the size to be 0, and then we're going to call ensure capacity. We'll talk more details about it a little bit later, but I will show you the code pretty soon. And notice that we're going to pass the default capacity. So this doClear is going to reset the size to 0, and then we're going to just create a new array from scratch with the default capacity. We have a size method that just simply gives us the current size of the array. We have a Boolean method isEmpty, which is going to tell us whether the size is 0. So if size does equal 0, it's going to be true. If it's not 0, it's going to be false. We have another method called trimToSize, and what this does is it will actually remove unnecessary items. So if we find that we have so much space allocated for the array, but we don't need that much space, we can actually trim down the actual capacity of the array. We then have the get method. So this will return a specific item. We're going to pass an index. So we first got to make sure that we're within the appropriate bounds. If not, we need to throw the array index out of bound exception. And then if it is a valid index, then we're going to return that specific item. We also have a set method, so we can set the item at some index to some value, which we call new val. And if there was an original value in there, this will actually return the old value. So we first got to check to make sure that the index is within the appropriate bounds. And then we'll get the current value that's at that element. And then we're going to change the element to the new value and then return that old value. And then we have our ensure capacity method. So we're going to pass in the new capacity. And if new capacity is less than the current size, then we're just not going to do anything with it. And then what we do here is we're going to take the current items in the array and we're going to store it into an old array. So we're going to create another, at least array reference variable. We'll call it old. We're then going to set the new, we're going to create a new array for the items with the new capacity. And then we're going to take everything from the old array and just copy it into the items. That's all we're doing here. We then have an add method. And notice it's a Boolean method, which is fine. It's going to return true if this works and false otherwise. So we're going to try to add x at the end of the array. So the way we're doing that is we're going to call another add method where we're going to say we want to add this first parameter is going to be where we're going to add it, which will be the size, so the end of the array. And then we have the x variable, so that's what we want, the value that we want to add. We then have the add method itself where we're actually doing the adding. So we specify the index and the value. So we first check to see if we need to change the capacity. So if the length of the array equals the size, then we need to increase the capacity. So we'll just simply double it and add one more element to it. And then we would make some adjustments to the elements. So whenever we add it, we need to move some of the elements depending on where we add it. So like if we add at the beginning of the array or in the middle of the array, we need to shove elements over. So that's what this code is doing here. And then finally, we would put that value at the correct spot and increase the size. We then have the remove method. So we're going to remove the item at the specific index and we'll return that value. So we need to get that value. So we're going to store that in removed item. We're then going to use this for loop to shove the elements over one place to close the gap. We're going to decrease the value of the size and return the item. And then we have the iterator method. So this is going to create a new iterator where we will create a new object of the ArrayList iterator class. So that's what this line is doing here. So that's going to call the constructor for the ArrayList iterator class. So let's take a look at that real quick. So we see here that we have an integer variable called current, which is going to give us the current position in our array. We then have an hasNext method, which just makes sure we're not at the end of the list. So as long as current is less than the size, then we're not at the end, so it'll return true. We then have our next method right here. So we're first going to check to make sure we're not at the end of the array, because if we are, then we need to say that there is no next item. And then otherwise, we will return the current item, and notice that we increment the value of current, so that way we move on to the next item so we can get that the next time we call next. And then finally, we have the remove method, which removes the current item, and we do have to use myArrayList.this.remove. And we'll see a little bit later on why we have to do this, but this does in fact remove the current item in the array. And that's the complete class.
Like its collections API counterpart, there is some error checking to make sure that we have valid bounds, because if we try to access an element outside the array bounds, that's going to be a problem. So we do check that. With that said, there are some things in this code that is missing. We're not checking for any structural modifications that could invalidate an iterator. It also doesn't check for an illegal iterator whenever we use the remove method. So it's probably a good idea to make sure that those checks are included in the code. We see that we store the size and the array as our data members. And then we also have a clear and a doClear method. Both of these would clear the contents of the array. Now, the purpose of doClear is so that we avoid having to invoke an overridable method in the constructor. The constructor just can call clear, but we don't want it to have it call an overridable method. And then we also see that we have some of the basic operations such as size, trim to size, is empty, get, and set. Let's talk a little bit about the ensure capacity routine. So what this does is it just saves a reference to the original array. We can then create a new array with the updated capacity and copy the contents of the old array into the new array. So if our new capacity is larger, we would create an array with a larger size and then copy everything from the old array into the new array. And now we have a larger array. We could even shrink the underlying array. So if our new capacity is smaller than the original capacity, then we will shrink down the array. But this is only going to work if the new capacity is at least as large as the current size of the array. If it's not, we're just going to ignore the request. We're going to say, nope, we already have so much stuff in the array, we can't shrink it less than what's already in the array. Now we should also mention that when we create the new array, generic array creation is illegal. I can't just say create a new array of any type. It doesn't work that way. I'm not allowed to do new any type and then square braces. So as we saw in the code, what we do instead is we'll create an array of objects. That's perfectly fine. We just have to typecast it to the appropriate array type. This will give us a compile warning, but it's better to have a compile warning than a compile error. So this is perfectly fine. We have two versions of the add routine. So the first one is just going to add the item at the end of the list. And then the second one lets us add an element at a specified location. The first version can be trivially implemented by calling the second one, where we just say add it at the end of the list. So this second version is actually computationally expensive because it's going to require shifting all the elements that are or after the specified position an additional place higher. So we have to move everything over by one spot. Another reason why this is expensive is we may have to increase the capacity, and that is really expensive to do because we're going to have to copy everything in the array and store it in the new array with the larger capacity. Now, to help avoid having to do this a lot, if we do expand the capacity, we're going to make the capacity twice as large as the size, just so it doesn't happen again unless we increase the size by a lot. Now, the remove method is actually very similar to add as far as how we're approaching it. All we're doing here is just we're taking the elements that are at or after the specific position that we want to remove, and we're going to shift it one position lower. So here we're saying remove at a specific spot. So we just take everything from that point onward and move it down one place. The last routine deals with the iterator method and the implementation of its associated iterator class. So this method just simply gives us an instance of the ArrayList iterator class. Now, what is that? That is the class that implements the iterator interface. So the ArrayList iterator class is going to store the notion of a current position as a variable, and it's also going to provide the implementations of the hasNext, next, and remove methods. Now, what's the current position in this case? Since we are dealing with arrays, the current position is going to represent the array index of the next element that we're going to look at. So initially, the current position is going to be 0.